It's Tuesday, the 15th of December. My name's Juan Brown. You're watching the Blancolirio channel. And just recently, the NTSB has released the factual report on the tragic loss of the B-17-909 back on 2 October of 2019, Bradley Field, Windsor Locks, Connecticut. So let's start with a brief summary from the chairman's factual report. On October 2nd, 2019 at 09:53 Eastern Daylight Time, a Boeing B-17G November 93012 operated by the Collings Foundation was destroyed during a precautionary landing and subsequent runway excursion at Bradley International Airport, BDL, Windsor Locks, Connecticut. The commercial pilot, that's the pilot in the left seat, the air transport pilot, that'd be the pilot in the right seat, and 5 passengers were fatally injured. The flight mechanic / loadmaster and 4 passengers were seriously injured, while 1 passenger and 1 person on the ground incurred minor injuries. The local commercial sightseeing flight was conducted under the provisions of Title 14 Code of Federal Regulations Part 91, that's General Aviation, in accordance with the Living History Flight Experience Exemption granted by the Federal Aviation Administration, FAA. Visual meteorological conditions prevailed in the area and no flight plan was filed for the flight which departed BDL at 09:47. So the weather was not a factor for this accident. Now a little bit about the living history flight exemption from the FAA. We've talked about this before in this channel. For years, warbirds have been operating, but it's been the purview of very wealthy people to be able to operate these warbirds. They're extremely expensive. In order to continue to operate warbirds, warbird folks worked together with the FAA, and I believe around 1995 or 1997, they worked with the FAA and got together this Living History Flight Exemption program, which allows you to take a warbird type aircraft like a B-17 or a B-24. These are aircraft that were designed for wartime and have no provisions similar to a air transport category aircraft or an airline type aircraft, and allow operators to carry passengers for hire on a donation basis, similar to a Part 135 type of operation. But in order to comply with the Living History Flight Exemption, the folks operating these programs developed a flight management program very similar to a Part 135 operation, complete with all the manuals explaining all the training and all the different safety programs that they needed to comply with, and all of this is overseen by the FAA. Now, a brief rundown on the flight itself. The crew arrived at the aircraft about 8 o'clock in the morning, and they put about over 130 gallons of fuel on board the aircraft to bring the total fuel on board the aircraft up to about 800 gallons. Plenty of fuel for all 4 of these engines. Each fuel tank on this system is tank to engine operated on the B-17, so that gives each engine about 200 gallons of fuel apiece. The fuel report, the extensive fuel spectrometry that was done by the NTSB indicates that the fuel was the correct octane and that it was in good condition and no water was in the fuel at the time of this flight. The 10 passengers were assembled in the terminal, and the crew chief flight engineer gathered them up and headed them on out to the aircraft to get them loaded up. All the passenger witness statements state that they were not briefed on emergency procedures of how to egress the B-17, nor were they briefed on how to use the military-style bayonet web old-school seat belts. And some of the passengers testified that they had a lot of trouble working with these seat belts. They also were unable to cinch these seat belts up tight and were told to not bother cinching the seat belts up tight because they're too difficult to uncinch. Once the passengers were loaded into the airplane, the engine start sequence was attempted. On the B-17, you have 4 engines, and from left to right, they are numbered engine number 1, number 2, number 3, and number 4. On the B-17, the normal starting sequence is to start number 3 engine first because it has the generator on board, or it has a generator on board that can recharge the battery. Plus, it's usually the co-pilot that's starting the engines, and he wants to start that engine closest to him first so he can hear what's going on. Followed first starting number 3 engine, you then start number 4 engine, then number 1 engine, and then number 2 engine. The crew reported some moisture in the morning air there at Bradley, and a common problem or a fairly common procedure for radial engines is to do something called blowing out the mags. The magnetos, the ignition system, which we're going to talk about extensively inside, and that moisture trapped in the mags produces a weak start, a weak spark while trying to start the engines and makes the engines hard to start. So the crew attempted to start number 3 engine. It wouldn't start, and so Mac directed the crew chief, or the flight engineer, Mitch, the person whose crew position is standing in between the 2 pilots, to go out and blow out the mags. This is Mitch's first time at doing this operation, so Mac talks him through it. The crew gets the mag blown out on number 3 engine and gets number 3 engine started. They go then to start the number 4 engine, the second engine start, and that engine won't start. So they have to shut down number 3 engine and blow the mag out. The mags, each engine has 2 magnetos. Again, we'll talk about this more. They blow out the mags in number 4 engine, come back, they get number 3 engine started, and number 4 engine started, and number 1 and number 2 engine started. They get all 4 engines started and head out and do their run-up. Run-up checks good according to all the witness testimony in this report. When I say run-up, that means typically you do a run-up to check the magnetos and the propeller, carb heat, oil pressure and temperatures. Get all your pre-flight checks done, and this crew elected to taxi out and do a intersection departure on runway 06 at Bradley with a little more than half of the remaining total amount of runway left. Within a matter of a minute or 2 after takeoff, and we'll go inside and look at this in detail, the crew begins to have trouble with at least one of the engines, if not 2 of the engines. As soon as the gear comes up, Mitch, the flight engineer crew chief, and the normal procedure is on these living history flights is to begin to allow passengers to roam about the airplane and check out the different battle stations on board the airplane. So he does that, and folks start moving up into the nose turret. Mitch comes back up to see how things are going on takeoff or on climb out there, and Mac tells Mitch, Mac, the aircraft commander in the left seat, Mac McCauley, who's got years of experience flying the B-17, informs Mitch, the crew chief flight engineer, that he wants to shut down number 4 engine. Mitch thinks, no, we're not ready for that yet. We're still climbing out. It's not clear if Mitch voices this to Mac, but Mitch says in his testimony that Mac reaches up and, quote, cages number 4 engine. So Mac, the pilot flying the aircraft and the aircraft commander, doesn't direct the number 4 engine to be shut down, but simply does it himself. More on that later. As soon as Mitch realizes that number 4 engine is shut down, and they were still climbing out at a fairly low airspeed, they're perhaps about 125 miles an hour at this point, Mitch goes down and regroups all the passengers and have them get back to their seats and strap in. At this point, it's unclear as to what is going on with number 3 engine. There is some discussion as to whether there was additional problems with the number 3 engine. But regardless, the crew elected to come back around for a precautionary landing. The crew did not declare an emergency with the tower, and they instead staggered around the pattern and came all the way back around and landed on runway 06, and we'll take a close look at the NTSB data. They got no higher than about 600 feet above the ground, and they achieved no airspeed faster than 125 miles an hour and spent most of their time in the pattern, and you'll see the eyewitness video, at speeds of about 100 miles per hour or less. Somewhere on the downwind leg, the gear was extended. Now, for a 2-engine landing and pattern and approach on a B-17, you would typically not want to extend the landing gear until you have landing assured. But regardless, the landing gear was extended on the downwind. And the crew basically was trading altitude for airspeed in an effort to maintain flying speed and minimum control airspeed on a multi-engine aircraft. If you lose power on one side of the aircraft and you have a lot of power on the remaining engine or engines, this thrust will tend to roll the aircraft over. And there is a minimum speed that, once obtained, if you put enough thrust on these engines, it will roll the aircraft over and you cannot stop it. This VMCA number is not, well, was never really specified in a B-17 because, again, this is a warbird type aircraft and it's not an airline type aircraft where they're required to have all these numbers worked out. But Mac is doing the best he can to keep the aircraft flying on the downwind, and it's presumed that Mac is carefully reducing the power potentially on the number 1 outboard engine, reducing that power to prevent this aircraft from losing control of this aircraft to a VMCA roll, or minimum controllable airspeed in the air type of roll. His pattern, unfortunately, is already set up where he's got to do a right-hand pattern return to runway 6, turning into the dead engines, which is going to exacerbate this VMCA problem. And he ends up, basically the crew ends up running out of altitude, airspeed, and ideas about 1,000 feet short of the runway. The B-17 begins hitting the runway obstruction lights. It's still in a bit of a right bank turn, and according to eyewitness testimony, it sounds like Mac pushes the power up to full power on the remaining 1 and 2 engines, and what power he could get out of number 3, we're still unclear if number 3 was producing power at all. Once the aircraft touched down and just swerved it, and it appears as though the aircraft accelerated into the tanks that it ended up hitting, perhaps as if he was trying to clear the tanks. This, at this point, is very unclear. So let's go inside and take a closer look at the data. Here's the NTSB Factual Report docket. 56 docket items with hundreds of pages of testimony and data. So where do we start? For those unfamiliar, let's start with the B-17 aircraft itself. November 93012, known as 909 in the Warbird circuit, is a 1944 B-17G model powered by 4 Wright 1820 engines. These are radial engines using a Hamilton standard full feathering propeller. The landing gear, it's a tail dragger configuration type aircraft with the tail wheel in the back, and the main landing gear is raised and lowered electrically. Interesting tidbit about the electric raising and lowering of the landing gear on the B-17. Once the gear is lowered, I believe there is a thermal time limit on the electric motor that lowers the gear. You cannot quickly retract the gear once the gear is lowered. You have to wait and cool those electric motors off that lower the landing gear before you retract the landing gear. So once you lower the landing gear, you're fairly well committed for a while. The 4 Wright 1820 engines, number 1, 2, and 3 on this aircraft were overhauled around the 2018-2019 time period and had around 250 to 290 hours since major overhaul. Number 4 engine was overhauled in 2015 and had about 1,100 hours since major overhaul. The TBO, the recommended time between overhauls, is not published in this report, and I don't know if it's a hard set number for these 1820 engines. However, the TBO for these older radial engines would be about on the order of 1,200 to 1,400 hours would be the recommended time between overhauls. This is an example of what I mean by a full feathering propeller. Here we see number 2 engine feathered. Number 2 engine is shut down and feathered. You need to feather a failed engine in order to minimize the drag of the windmilling propeller. If you do not feather an engine and that propeller continues to windmill, especially if it's in the high RPM, low pitch setting of the propeller, that creates a tremendous amount of aerodynamic drag. Feathering the propeller reduces that aerodynamic drag and makes controlling the aircraft easier. 909 was modified to carry passengers up to 10 passengers back in 1995 as part of the Living History Flight Exemption. This modification was approved by the Orlando, Florida Flight Standards District Office back in 1995. So here's your forward entry point for the B-17. Here's sliding cockpit windows, both on the left and right side, which also allows another point of egress. Here's what it looks like up in the nose section of the aircraft. You cannot occupy this section of the aircraft for takeoff or landing, but is one of the sections you want to go see during the tour. Here's the radio room. This has been modified to have 2 additional seats. Here, one on the left and I believe one on the right. And I believe overhead of the radio room is a plexiglass hatch making, there you can see the shadow of it, another point of egress for the aircraft. The seat cushion, I believe, is shown out of the way here in the radio room. There you can see the military-style web belt that the passengers were struggling with. Here in the aft section of the aircraft, I believe, is 5 more crew seats available, again shown with the seat cushions in the up position. You're basically sitting on the floor in the back of the aircraft. So as you can see, this is obviously not airline-style seating or safety equipment. This is why these limited category aircraft, that's the certification that they're level that they're certified at, limited category, why these aircraft need a living history flight exemption from the FAA in order to operate and carry passengers. Another view of the aft section showing the waist gunner positions, and up to 5 passengers would sit back here for takeoff and landing. Again, strapped in with the web belt, bayonet style military seat belts. And here's a closer look at how that seat belt operates. Here's the lever or bayonet that snaps down into this notch here, which latches this belt here. And normally you would have shoulder harnesses, and they would strap in right here. They would loop through this buckle right here and give you a pair of shoulder harnesses, though I do not think this aircraft had shoulder harnesses, only this lap belt. And not shown in this picture is the cinching apparatus, which the passengers were told to just leave it alone. Don't bother trying to cinch these seatbelts up because they're too hard to uncinch. And looking aft here from the waist gunner's position, we see the other egress door, the rear door to the B-17. That would be on the right rear side of the aircraft. From 2016 to 2019, over a 3-year period, 909 flew 838 hours and was averaging a little under 300 hours per year. The aircraft weighs, empty weight, 34,000 pounds. The wartime gross weight, the maximum that you can load this aircraft down to during wartime, is 59,000 pounds. On the day of the accident, the aircraft weight and balance was estimated to be a total ramp weight of 46,135 pounds, well under the 59,000 pound max wartime gross weight. And the aircraft's center of gravity appears to be balanced at an estimated 25 to 27% of mean aerodynamic chord right here. And the range for the B-17 is 20 to 32% mean aerodynamic chord. So the weight and balance for this aircraft was good. The whole idea of having the living history flight experience exemption is to provide the vehicle for FAA oversight of your operation. Now, this FAA oversight was performed by the FSDO, the Flight Standards District Office out of Orlando, Florida, the FAA office in Orlando. Now, in order to comply with the exemption, the Collings Foundation has to produce, create, and the FAA needs to monitor the following manuals: a general operations manual, a training manual, qualifications manual, a maintenance manual, a management manual, and the inspection program, plus safety management. But what happened to the Orlando FSDO Office of Oversight? The Orlando, Florida FSDO had jurisdictional oversight over the Collings Foundation. Remember, we talked about that back in 1995, the approving of the seats. During an interview with the Orlando FSDO office manager and assistance office manager, they indicated that prior to 2017, there was a point of contact assigned to the Collings Foundation with the responsibility for answering regulatory questions, but that POC did not do any ramp inspections or conduct any en route surveillance. That POC then passed away in 2017 and was not replaced by the Flight Standards District Office. During the interview, when asked how the Collings Foundation was to get in touch with the FSDO, since there was no POC assigned, the office manager indicated that we have a front desk that people can call into. The Collings Foundation chief pilot stated that in a conversation that after the POC passed away, the FSDO advised him to use a general email mailbox for their correspondence with the FSDO. The chief pilot further stated that they would send notifications that were required by their exemption letter to the general mailbox, but after several of the emails and notifications were not answered, the Collings Foundation stopped using the general mailbox. As a result, the Collings Foundation operated with minimal to no FAA oversight. Let's take a quick look at the background of the flight crews. The accident crew consisted of a captain, co-pilot, and loadmaster. Now, I called Mitch a flight engineer as he's operating between the two pilots, but he's technically a loadmaster in this position, crew chief, handling the passengers. The captain held a B-17 type rating. Remember, this is Mac McCauley, the highest time B-17 pilot in the United States as of today. The co-pilot was not type rated in the B-17, nor was he required to be. According to the FAA, the loadmaster was not a required crew member by regulation. However, every flight had a loadmaster assigned, and his duty was to assist with the passenger handling and briefings, according to the Collings Foundation chief pilot. I believe that is a requirement of their living history exemption, that the loadmaster be on the aircraft. So Mac has a clean record. He's 75 years old, 14,500 hours of flying time. He did have a DUI back in 1998, but if you look at his ratings, Mac comes up through the civilian ranks. He's a private pilot by 1969 and then gets a commercial rating in 1996, multi-engine in 1999, multi-engine instrument, and then the B-17 rating in 2003. Mac also has an airframe and power plants mechanics license. Not only is Mac the aircraft commander of the B-17 and flies it the most, he's also the director of maintenance for overseeing the entire maintenance operation of the B-17-909. The co-pilot was 71 years old, and he's a retired airline pilot. You can tell by his ratings. So private pilot in 1967, commercial 1968, 73. So a steady progression through the ranks, flight engineer, air transport pilot, and then his career as a airline pilot, 737, DC-10, 757, 767, and instructor as well. So ATP rating, flight instructor, and second-class medical. Again, these are all volunteer positions at the Collings Foundation. His check ride performance is satisfactory, and he indicates a total flight time of 22,000 hours. Now let's take a look at the Jepson plate for Windsor Locks Airport. This aircraft taxied out, I believe, on this runway and did an intersection takeoff where these two runways intersect on runway 06. Runway 06 intersection takeoff. That distance looks like 1.17 miles or a little over 6,000 feet. Plenty of room for a B-17 departure. However, investigators are still questioning the judgment of the pilot to use an intersection departure as opposed to all of the runway, especially given the trouble starting the engines. Note also that the elevation of the approach end of runway 06 is 173 feet above sea level. Now let's take a look at the NTSB data. Orange numbers on the left here indicate time. Orange numbers on the right indicate altitude, GPS altitude, mean sea level. So remember, the airport elevation is about 180 feet. This entire pattern from start to finish, from 48 minutes to 53 minutes, should be just around only a 6-minute long flight total. So we see the altitude increasing until about this point here, reaching a maximum altitude of about 745 feet above sea level, and then a steady loss of altitude as they return back to the airport on the right downwind for runway 06. Now, investigators are already Monday morning quarterbacking this thing and saying this crew would have been better off had they just hooked it around and come right back into this runway here with plenty of distance to land on this runway rather than continue all this maneuvering around back to runway 6. So remember the configuration that Mac's fighting with here. He's got number 4 engine feathered pretty quickly, like about a minute after takeoff. We'll take a look at that in a second. Number 3 engine appears to be windmilling and creating a lot of drag. And at some point, the video evidence suggests or shows for a fact that the landing gear is down somewhere here on the downwind. So this sets him up for a pretty sharp turn to final here for the last bit of the arrival onto runway 06. So let's take a closer look at that. And here it shows a steady turn into the ILS lights here on runway 06, and that turn continues on into the de-icing tanks where they ended up right here. There's also an acceleration in speed through this section of the NTSB data. Let's take a look at that. Here's the altitude shown in a graphical representation, GPS altitude in MSL, height above sea level, and here's the terrain from the Google Earth. So it shows a maximum altitude reached of about 750 feet and then a steady downhill descent on downwind back to runway 06. Here's an old chart straight from the B-17 manual showing the best 4-engine rate of climb airspeed here at 40,000 pound weight at sea level. 4 engines indicates the best rate of climb airspeed in miles per hour is about 120. Here's the NTSB airspeed data showing the highest speed reached shortly after takeoff, 125 miles an hour, that best rate of climb speed. 125 reached there, and then just a steady decrease in airspeed all the way through the downwind and final base turn. And then here, just before 0953, there is this one last acceleration all the way down from just under 95, a little over 90 knots, all the way back up to 105 knots. And this speed is getting very close to the aircraft stall speed. And of course, Mac is also fighting the, as we discussed earlier, VMCA, the rolling tendency of the aircraft, given the thrust on the good engines versus the lack of thrust on the dead engines. Here's the rate of climb in feet per minute. He initially achieved about 1,000 foot per minute rate of climb, which corresponds with the charts for a normal 4-engine rate of climb. And then it decays rapidly, less than 1 minute after takeoff, as Mac Cage's number 4 engine, that rate of climb, he starts exchanging altitude for airspeed right away. And here's the 0 rate of climb line right here. So he's varying closely. Well, he's descending all the way back to the runway 06. Now let's take a look at the weighty eyewitness video of the actual touchdown of the B-17. Here's the aircraft in a right-hand turn, just about to begin hitting the lights off of the end of runway 06, 1,000 feet short of the runway. Now, we can't critique these eyewitness videos. Remember, they're witnessing a tragic event. They're watching it with their own two eyes and not paying very close attention to where the viewfinder of the camera is. So we lose the view of the aircraft for a few seconds in this shot. So let's do that again. You can hear the roar of the engines. He gets the aircraft righted as he heads into the de-icing tanks. So what could have brought this B-17 down? What caused these engine or engines to begin to fail so quickly after takeoff? And I've gone on long enough today, so we'll have to stay tuned for part 2. We're going to dive deep into the power plant investigation regarding specifically engines number 3 and 4, what the folks down at Vintage Radials found in their investigation of these radial engines, tearing them apart, and we're going to get deep into the engine's ignition system, the maintenance of that ignition system, and how that ignition system works on the Boeing B-17. So stay tuned, stay here for part 2. Again, thanks for your support on Patreon that makes this content possible, because most of my content here in December has all been demonetized by YouTube. Thank you for your support. See you here.